Hello, welcome to FEMAP Real FEA Made Easy series. In this series we would like to share with you our FEMAP experience, giving you some hints to perform Real FEA on the easy way. Today we will focus on another powerful FEMAP tools which extracts mid-planes from the sheet solid model geometry for its shell meshing. For thin-walled solids, it's recommended to use extracted mid-surfaces from thicknesses for creation of shell mesh instead of solid mesh. This operation reduces model size and increases model accuracy. In many cases, mid-surface generation can be done automatically in FEMAP. For mid-surface extraction from thicknesses for creation of shell mesh, two main methods are used in FEMAP. Geometry mid-surface automatic method for sheet solids with variable thicknesses, and the second one, geometry mid-surface offset tangent surfaces for sheet solids with constant thickness. Both methods require use of assigned mesh attributes for definition of attributes before element meshing. Automatic mesh plane extraction will automatically create a mid-surface representation of a solid mesh or between selected surfaces. The method requires a selection of the surfaces, definition of target thickness, and optionally set some additional settings. Mid-plane extraction by offset tangent surfaces method is used only for solids with constant thickness and requires selection of seed surface and tangency tolerance, mid-surface tangent offset value for offset the selected surfaces towards the middle of the solid part. The offset surfaces will be automatically stitched together by FEMAP as the last step in this procedure. Let us see the following examples which show how to use both methods in FEMAP. Open the model for use of automatic mid-plane extraction method, and starting with geometry mid-surface automatic and selection of all surfaces. Select thickness as mid-surface target with additional options like combine, variable, and tangent. Mid-plane will be extracted for all thicknesses from target defined and below. The next step will be definition of meshing attributes. Mid-surface attributes with material and consolidation of thicknesses. In this case, we are going to see three different thicknesses which are present in the model. So it will be easier to see when we consolidate thicknesses of the model in the assembly, and you can handle these thicknesses a little later on. The next step will be, of course, meshing. When we start this procedure with mesh control size on surfaces, selecting all of them, and preparing definition of the mesh size for the whole structure. The final step of this meshing will be mesh generation on surfaces with meshing attributes, and optionally using max squat option for meshing generation. As you can see, as a result, you've got very nice mapped meshing, all this mid-surface generated. The second example will show us usage of the second method, mid-plane extraction by offset tangent surfaces. We are going to select our geometry and method, and after selection of this command, we are going to select seed surface and tangent tolerance for the whole model. After that, we need to define distance for mid-surface tangent offset to be used for offset of the selected surfaces. When we decided about that, so we can simply delete original solids before meshing. Of course, we have to add some mid-surface attributes as element properties, similar to the first method. The final step is the meshing. Also define mesh control size on all surfaces and creation of the mesh size for a structure. When it is done, we can continue with mesh geometry surface using meshing attributes and as well max squared options to generate final mesh. Geometry mid-surface tools like Geometry Mid-Surface Automatic, Geometry Mid-Surface Offset Tangent surfaces can be efficiently used for the model which will be meshed using shell elements. For more information, please launch Chapter 3.3.4 from FEMAP help folder or contact us using email femapsupport@femcomp.se. Thank you for watching.